To understand the benefits of heat treating processes first requires an awareness of metal and alloy structures. When a molten metal solidifies, the atoms arrange themselves into definite patterns called crystal structures. The two most common crystal structures in metals are body-centered cubic and face-centered cubic. These crystal structures grow uniformly in all directions within each developing crystal. As the metal cools, these crystals are confined by the adjacent developing crystals, forming grains. The line of intersection between grains is called a grain boundary. Because the grains form independently, their crystal structures develop tilted in various directions. All atoms in these crystalline structures are held in place by electromagnetic attraction to neighboring atoms. If a force or load is applied to a metal, these electromagnetic bonds stretch, allowing the atoms to move slightly. When the load is removed, the bonds pull the atoms back into position. If the applied force exceeds the metal's yield strength, those electromagnetic bonds will break, causing permanent stretching or deformation. To make metals stronger and more resistant to deformation, it's necessary to strengthen their crystal structures. This is done by adding alloying elements, which are other metals or non-metallic elements like carbon. The addition of an alloy introduces foreign atoms within the crystal structure of the base metal, disrupting the structural uniformity. This disruption results in increased strength.